right. Hey, everybody. Thank you. I just wanted to thank everyone for having me here. I expected to see 4 or 5 people, and this morning they were like, oh, no, there'll be like 100, and I started to panic a little. But basically, this is a project that evolved out of a great passion I have for not eating polluted food and my geekiness. And so I've been working on building a self-sustaining hydroponic system in my house. And this is just a very introductory level look at some of the work I've been doing. The outline for today, I'll introduce myself, this project, an overview of the website where the monitor lives, and then we'll tiptoe through the repo. We'll look at some Raspberry Pi scripts and the Python Anywhere website. And I tried when I was putting this presentation together to think of ways where you could go home, pull down the code, not know how to manage a server, which is probably optimistic because even Python Anywhere makes you do some ugly work. Really, the static files are the ugly part. But that you could go home and you could get this running without a ton of back skills. So hopefully this won't be too painful. My background, I am a data science instructor at General Assembly in Boston. I've been doing that for about 5 months now. And prior to that, I was a public health data scientist for the state of New Hampshire. Did a lot of epidemiological, geographic, and temporal studies for the state. And prior to that, I was an art teacher at a high school, which is where I learned to code so that I could help my students find futures that were bright. And I fell so in love with it, I was like, guys, gotta go. I have a BFA from Rochester Institute of Technology, a post-bachelor's in environmental biology, which is where the geeky plant part came in. And I'm currently enrolled in a master's degree in data science through City University of New York. Where the goods are, I have for you guys a repo with everything. The hydroponic monitor, it's on GitHub. I have links to MLab, which is where all the data is stored in MongoDB on MLab, and the Raspberry Pi pushes the data right up to the repository, and then Python Anywhere grabs it and implements it and pulls a picture. I even store pictures in there. I had to learn to use GridFS to break up all my photographs into little bitty pieces. And it promotes a web page. I will tell you before I get there, despite having been an art major, I am not a web developer. And so I did a little CSS for you, but it may only be CS. So, all right. And here is the monitor itself, the web page. Oh, where'd it go? It's down here. 2 screens. Don't laugh, I saw you giggle. That's not nice. All right, so this is the web page itself. Wow, it's not sizing for that one. I'm gonna. Well, that's beautiful. It's probably as good as we're gonna get on this screen. It's not sized the same. So here is the basic front page of the website. It has just simple navigation. Right now, that's the most recent photograph of my cucumbers and Thai basil, which are growing in the secret room the dog's not allowed in. And the color's a little bit wonky because the last couple of years they came out with these great lights that are LED and they're red and they're blue and they're not continuous tone. And so the leaves don't fully reflect the color and the room sort of looks spacey. That's the Raspberry Pi doing its best to autocorrect it. And down here are some links that I have not filled in yet, but I promise I'll get you stuff. And so this is the home page. And then the monitor tracks nutrient temperature, air temperature, humidity, and light levels throughout the day. And then it takes 1 photograph every hour. So it takes readings every 15 minutes, and I have it charting them. And then it's photographing it once per hour. And so each page just has a simple chart. And this is made with Bokeh and Flask. And so you can scan over it. I don't know if you'll be able to read it, and it has point readings for any given point in time throughout the day. I have a more detailed one that I look at home, but it would be scary.
Why does it look like that?
What is it?
Why does it? What is that on purpose? That it's getting cold?
No, in my house at night with the fans on, the temperature differential is pretty big, and so it actually drops off and climbs back up. And it's not a very large, like if I were doing true commercial level hydroponics, you'd have 700 gallons and it would barely move at all. But because this is like a 3-gallon container, it's actually kind of vulnerable to the ambient temperature. And you'll see the air temperature also changes. It's a little less stable, but it precedes it. And humidity, here's the one that's usually all over the place. Yeah. And it even changes, I notice, if I go into the room for a long period of time, it goes up a little. It's a very small room. Okay. Yeah, so. And light levels. And this drops off because I have the light on a timer. Yeah. I want the plants to sleep and get their oxygen at night, do all their crazy, goofy stuff, and grow big. And so this is just a super simple website. There's nothing extremely impressive about it, except that I can be at work and when nobody's looking, get on my phone and see if anything's falling apart at the house. Not that there's anyone to fix it, but I would at least know when I got home my plants would be sad. And so that's the website and the goodies. All right, I'm actually going to go back 2 pages because here's where the links are. Here is the and it's still loading down here. Here's where everything is, and I encourage you to go steal everything. And give me feedback because I'll own it. Python is not my primary language. I am an R person. Don't hold it against me. But I like things that are overly complicated and challenge me. So here are the camera scripts, super, super simple. I think if you were to use this, like I actually got the idea for this project when I was teaching high school. And I was asked to teach an introduction to technology class, and I looked at what they were doing. I'm like, a popsicle stick bridge, and we're gonna break it, and we're not measuring. This is like 1912. And I went to my principal very submissively, can I rewrite this? She's like, please. And so the first thing I did was I realized no one in the room had ever used a tool. So we measured, we cut, we built a woodshed in the classroom. Then we didn't close it in. We put shower curtains around, stapled it up, hung up lights, and then we had a design competition where they broke up into groups of 4 students and researched hydroponic methods, produced an entire project proposal with diagrams, and then presented, and then the other groups voted on them. And so if 2 people did the same kind, like 2 of them did raft systems, only one could win, the best presentation won, right? And so you couldn't vote against yourself. And then all the groups that had to go back and redesign absolutely made the best setups. And so I kind of fell in love with hydroponics there when the kids would come in and we'd have cucumbers and lettuce and tomatoes in our classroom under the lights. And if you are a teacher, you should consider doing this because on parent-teacher conference, no one asked me about their kid. Like everyone just stood there looking at the cucumbers and the 3D printer that was running right next to it. And they weren't like, why is my kid getting a B? It was awesome. So I would recommend it highly. But I fell in love with it. And so when I left, I started thinking, well, how can I turn my house into my classroom? And then the next extension for me was this Raspberry Pi project. And so simple camera script right here. Something you could probably look up and download 90% of it on, from 100 tutorials. But the best parts of this are using PyMongo and GridFS to push those photographs out to MLab, which means I can share them with anyone. They're saved. They're in a distributed system, a non-SQL-based repository. And then instead of trying to figure out how to save them to Python Anywhere or move them around, when you pull the page, Python Anywhere just goes and grabs the most recent photograph and the last 70 sensor readings and charts them for you. And so this is the guts of the photograph. Right? Just instantiate the camera, adjust the resolution, rotation, because of course I mounted the camera upside down. Give it a timestamp. Well, right now it has that 3-inch little ribbon cable where you're not sure what happens, but the meter-long cable's on its way. And so I'm actually going to redesign the entire room, and then the dog really can't go in there. Right. And so you capture a picture, and it's just a while loop. I run this in a background script, and I have battery backup on my Raspberry Pi, so if the power goes out, it keeps running. If you were to implement something like this and didn't want to go through all that added hassle, I would run a reboot command line to keep it going. And so that captures the photographs, and then I have a sensor script, which you would think would be really complicated, but this too is just a very, very simple script. How far can I walk? Oh, I'm untethered. This is awesome. And so it uses this one wire, the nutrient sensor uses one wire. I use an Adafruit module for the humidity sensor, which is also what I use for the air temperature, even though it probably throws out a little bit for some heat. And the TSL 2561 is my light sensor reader. And so I set up with, those are not my real logins, by the way. I changed those for your good. Instantiate the Mongo, make connections, give it ports, give it IDs, all the login stuff that it wants. And where it says collection equals DB sensor, that's where you tell it the database and the collection name is sensor. And so I actually store this in two places. I put it in MongoDB, but if I want to play with it at night, I have it saving in a CSV as well, so I could go home and just pull it up. And so I created a read function with instantiated each one of those and have it save out into an ordered dictionary. And the reason I have that dictionary is ordered is because of the CSV file. I want it to be consistently compatible. And then I just start another while loop, pull the observation with the nutrient temperature, the air temperature, humidity, and light levels, save it into a data frame and append it. That's what the mode A is. I don't know how many of you are pandas people, but us data geeks use it. Instead of writing to a data frame, you can just append it, and it slaps it right on the bottom, provided everything's in the same order. And then collection insert, do the exact same thing with Mongo, just put that one more observation in and tell it to sleep for another 15 minutes. It's been running flawlessly, except when I trip over the plug for, not everyone's skillful with their feet. But it runs pretty flawlessly and consistently, actually much better than I had hoped. But I did do, the one thing that I really found made this Raspberry Pi project so much better than some of the other ones is I bought one of those Raspberry Pi desktops. And it's a little black case, and you put it in there, and then it has this hat on it, and you can put a micro SSD drive on top. And so I boot from this SSD drive, and I'm no longer tied to the card that gets corrupted if you think poorly of it for a second. I know you've done that. You'd be like, what happened? 78th card this week, right? So I put it on that SSD drive. So I have 128 gigabytes of storage space, and it's faster and it's cleaner. And the only downside is you have to leave the lid off and kind of jerry-rig it to get the Pi cobbler out. But it's been pretty stable, and it runs really well if I don't trip over it. And so that's all of the Raspberry Pi, the guts of the Raspberry Pi. The really convoluted part of this project is actually in the Flask app. But what I wanted to show you is the setting up the Pi. In here, I have included I assume the basics that most of you've installed an operating system, but the development environment for working in Python, like some of you might like to work in idle, I am not that person. So I installed Spider 3. I did most of my work in there because I'm a data geek and we use Anaconda products as God meant it. So there is the one-wire device. That is the submersible waterproof temperature sensor. And it is just connected via, and there's the wiring diagram, and it tells you you need to jump it with a 4.7K resistor. Here's the wiring diagram for it with the Pi cobbler. I'm going to shrink that back down. So it shows you how to set it up. And that is a 26-pin version. If you're using the Pi 3, that's a 40-pin board, so you might need to reconfigure the numbers on it. But I even give you the numbers. Like, the numbers are set up, what pin numbers, the GPIO number are on there. So if you download this code, you should be able to just carefully check that you've plugged everything in the right place, not cook your Raspberry Pi. Never cook a Raspberry Pi. They don't taste good. And I just ran this little test script. Each one of my sensors I installed one at a time. I left them all together, but I tested them one at a time. I'm a firm believer in just incrementing your way up. So there's a little code to test it. If you get a reading, it's working right. And if you want it to be Fahrenheit, you can figure out how to do that. But I'm just trying to move us forward, you know. Here's a humidity sensor. It's a super simple little thing. You plug it in. Takes 4 wires, and you just request a reading from it, and it will send you back right here. Humidity and temperature equal to, once you install that Adafruit DHT package, equal to the instantiation of it with the GPIO 11 pin, and it's good to go. It pulls up, it runs perfectly. You see right down here, if you don't format this, you might get like 52 decimal places. I doubt very much if it's that accurate, so I just chopped it down. And the light sensor is the weirdest one. If you're not a photography major, lux probably means very little to you. But it's actually a good stable sensor, and it's pretty consistent, and its output has been fantastic. And if you have the mathematical capability to figure out how light translates into the generation of energy within your plants, and you're super, super geeky, I'm not saying I am, but if you're super geeky, you can translate that. So, and there's instructions on how to set this up in here too. I wanted to be sure that I gave you pretty much everything you would need, because you will be angry at some point. And here's a list of all the, oh, yeah, like that. What was that? Here's the parts list. The magnifying glass. Any of you who are over 30, you are not going to read anything on any of these sensors without like a magnifying glass and a reading lamp, maybe even a monocle. And so that's a really big thing. And the multimeter, you may or may not need that, but I like to test things a lot because I don't like to fry my, even though it's a $35 computer, I still somehow get mad. And so if you're working with kids on this project, I think showing them how electricity moves across a resistor and how the signal, like the energy changes when you do that, I think it's a really great project. And you can even build a tester with these tiny little breadboards that they have now. You can create male to female pins and just drop them right in and get one of those free Harbor Freight multimeters that they give you when you buy anything, and plug it in. And if you don't know if, like, you also need a microscope to read the bars on your resistors, you can just plug it in and get a reading. This is what it is. Like, is it working right? I just leave it set up. It's sort of stuck on the wall of my, I'm going to admit it, on the wall of my bedroom, right? And I just put it in there. It's working. It's not, right?
So you don't know all the color schemes for resistors? You don't mess with that stuff?
I don't even know the color schemes of my socks. I have a philosophy that you should not memorize anything you can look up, because complex thoughts are much more difficult to handle than small pieces of information, right? So when I'm teaching students in my day-to-day, they frequently are like, I want you to give me infinite code feedback. I'm like, no, I want to sit down and talk about the process that you went through. Your code is working. This is like your 3rd day with it. I don't think we should be optimizing before we even know what we're doing. Let's talk about concepts. And so I'm kind of that way with everything in my life, mainly because I'm actually not really good at details. I'll be honest with that. But yeah, I don't know the colors. And this is a list of everything with links. And you don't have to buy from any of these places, and I don't get money from them, but I wanted you to know what it looks like because I wasn't sure my descriptions would be good. So I'm going to go back and I'm going to show you the Flask app. It's not really difficult. This is my favorite part of it. I totally love Flask, but at the same time, I'm always mad when I'm working in it. Because their documentation is somewhat abysmal. It really is. It's not if you're a true developer, but I'm not. Like, I'll own that. I'm a data scientist. I write code to accomplish a task. The task is far more important. I go out and I figure out the code. It's not that I have anything wrong with properly functioning code. I think it's fantastic. So when you write documentation for something that's supposed to be a really simple module that's supposed to simplify something, then the documentation should also be simple. I think that's a good concept. And so the first time I built a Flask website, I struggled. But again, this is just the same thing you saw in the beginning of the Py instantiate the MongoDB, because now I'm going to pull the data back and create this tag to my gridfs. And then I wrote a function called image updater, and that may be the one thing that may or may not be working right. I'm getting images, but I'm not convinced I'm getting the most recent one. So that goes out and it pulls an image and it saves it into the static file. And then it goes, and the data extract function will go, it will grab the cursor, pull the data, drop it into a data frame, drop the ID out because it's like a 300-letter hash that I don't need in my data frame. Make that go away, reformat the date time, and it returns it as plot data. And then I wrote a generic chart function that every one of those pages uses with a dictionary that has titles and axis labels and colors based on which one of the sensors, and the name of the sensors for the column in Panda's data frame. Created a custom hover tool that just says sensor reading and the value. And this is all in Bokeh. How many of you have any of you used Bokeh before? I love it. It's so pretty. Do you like it? Yeah, I love it. All right, and then these are the actual, the decorator and the function that calls the home page. You can actually, I will actually go cut this out. That's not there anymore. It's not necessary. It's still there, but it's not necessary. So when you push out Bokeh through, there's multiple ways you can serve up the graphics. But for me, the easiest one is to break the components into the divs and the scripts and to push them out and plant them on a template page. And so you see where those scripts are if we were to come and take a look at the air temperature. Oh, yeah, and I used the CSS. There's a link in here. I went to a CSS generator to create table colors and stuff. Just drop it right in here. And the reason I did not put that in a static folder, there's one on every page, was that is the only thing that I have found sometimes Python Anywhere, the static folder is unpredictable. And so it kept losing track of things, which is why I'm not sure whether the image is pulling the right thing and it's just not getting in there, or if it's actually working properly. But so here you have, this is how you drop that graph in. You just use a double set of squiggly brackets and give it the div. You have to tell it it's safe or it won't put it up in the script. And then it interprets it and then it drops that chart right in the page. It's a pretty elegant, in my opinion, elegant implementation of a chart without having to move a full image over, and it allows that dynamic component to travel over with it. And these, all of them are basically the same index, with the exception of the index, because it has an image on it and a couple tables on it. You can go in there and pull out the CSS and put your own in. Really important things. Actually, this is probably one of the most important things that might trip people up. Because you're using Bokeh, they have an API for the widget that your web page will talk to. So your HTML has to have those links in there. And if it's not working and you feel like you've done everything else right, go and check the version. Go pip freeze and see what version of Bokeh you're running. and then look here, because they have to be exactly the same. And if they're not, that server's not going to happen. It's a deal killer. And I'm not saying I wasted 3 days at my last job trying to figure that out, but yeah, I definitely did.
You're not saying you threw anything through a window and finally...
No, but I renamed my computer. You should do that at least once a week, or you're not learning new stuff. And I have a README document here. I will own this. This is my first presentation about anything code-related that's not in a classroom, and it's the first time there have been more than 20 people in the room. So I'm not sure what you might like out of this, but I'm totally willing and hope to spend the rest of the time answering questions, because I think that it's a super fun project, and it would be easily transferable to, if you were a weather geek, you know, you could just hop this over and put it out on a bird feeder or a pole or something like that outside. There's many ways you could transform this, and I'm in the process of developing a conductivity meter and trying to break a pH meter. But they're both analog, so they require that I put it through something like an Arduino, so I just ordered a Python-based Arduino. I want one language. Questions? Yes. Yes, I read that manually. Yeah, I read that manually. Every time I check the nutrients and update them, I take readings on it. And anytime I notice that I perceive that the plant's leaf colors are odd, I will take a pH and a dissolved solids reading to make sure that it has enough food and it has the right pH. Because those are things that can really shut off the roots. They get pretty grumpy pretty quick if you burn them. And I don't really blame them. Could you say that again? Oh, no. So the question was, do I plan to take a stick pH meter apart? Well, yes, I did order an extra one, and it should be here within 20 to 58 days from China. But I actually found a couple sources other than Atlas that provide mass-produced open source boards and probes. And I'm sure they'll work. The difference is they're not going to be calibrated and set up but Atlas costs $400 and something, and these are $16. So when I left teaching to become a data scientist, I spent 8 months at Plymouth State University in New Hampshire with Mark Green, who's an amazing hydrologist, and he showed me the lowdown on calibrating both pH meters and EC meters, and we built all kinds of crazy stuff out of Arduinos. So my goal is to just test them across a wide spectrum and then get an equation and then update it as they corrode. Although, you know, I did think that I could put some little servo motors that just drop them in and then take them up and then rinse them and then dry them. So I could have it do it once an hour, so they wouldn't have to be permanently submersed. They could just it's kind of like a 3D printer for your hydroponics. Yes.
So this was wonderful. This was
really, thank you.
So much for doing this. Are there projects that you wish you could just describe? This is what you want, and then I don't know, people that want to like write code could jump in on this. Like, are there things that you wish you had time to explore? You get what I'm trying to say here?
Yeah, if I could quit my job and just geek out, there's a million projects. Why are you looking? Do you have a classroom full of kids that you're looking to do stuff with?
I mean, this thing is really cool. It'd be fun. Like, you've got other interesting kind of like avenues. Like, I was thinking maybe some kind of moving average kind of overlay or something where you correlate your data from like intentionally poison the plants and see how they die or something like that. Like,
dude. I spent my entire youth trying not to be a mad scientist, and here you are like, what happens if you torture the plants? They die and they don't like it.
You get what I'm trying to
yes.
say, right?
Actually, I think some great uses, like pulling all of these meters in might be overwhelming in an academic situation with high school or junior high school students. But if you were to just take, even if you didn't have plants, a giant bucket of water, say a 40-gallon bucket of water, and you put it in your classroom, and then you put one outside, and you dropped, temperature probes in, and then you taught them how to access a USGS API for the nearest airfield or meteorological station and the nearest stream, you could compare the changes in the water indoors and outdoors and from those readings. And those are kinds of things where kids can build like the questions why. And you know, they'll never get to the cause, but they'll start looking and charting and digging through numbers and then doing research, and you'd be amazed at the kinds of things they bring up. So that you could do that with those DS18 B20 submersible meters. They're like $2 each if you buy 20 or 30 at a time and wait 58 days. Yes.
PyOhio API. It's like a simple text messaging API, but it would be cool to add this where you could like set a range for different values, and if it goes outside the range,
Just tweet me. Oh,
so that'd be something cool.
I will never remember it if I don't write it down. That's awesome.
TWILIO. I actually haven't personally used it. I'm sure people in this room have.
That's super cool. Does anyone else have any questions, or you want to come over and play? So it is sensitive. Oh, he asked how the light sensor dealt with the limited spectrum. Right now, it actually deals with it really, really well. I don't have a long enough set of wires to put it as close as I would like to. Updating the entire wiring diagram and actually soldering on a board and building a permanent unit next week. It's pretty good. It senses all continuous light, and both that shade of red and blue are firmly entrenched in the visible light spectrum far enough in that it senses them. You clearly would have more light if it wasn't filtered, right? Anytime you attenuate a light source, you lose intensity. But the plant doesn't need the entire spectrum. It needs stimulation in certain areas. And so if you had light this bright, but you only could use this much of it, you might as well just have this much of the right light. So I find that it's working completely fine, and the meter's not acting wonky. The one thing I think I am going to do when I get home is order an infrared camera, because one of the things that you can frequently tell about plants when you're up close and personal is the health of the plant. Like spots will turn black or white on the plant if things are going weird, or if the pH is off, or if it's not getting the nutrition that it needs. And so by swapping that out, because there's no color integrity with that limited spectrum, it might be more useful as a diagnostic tool. And then I could build some kind of really cool computer vision, like machine learning thing that could go through and look at slide after slide after slide and try and predict when my plants were dying. So maybe it is something you could do.
I was thinking like a